Hello everyone, and welcome to our video, where our topic today is solar cells. So what might a solar cell be? Before I get into this, I want to use a quick analogy of sorts to help us better understand what a solar cell might actually be. And the best analogy for that, I believe, are plants. So our sun, as we know, helps to generate power and energy to our earth. And plants use this energy in order to help them grow. And they do this in a process called photosynthesis. And in turn, they help blossom and produce flowers and oxygen for us humans and other life here on Earth. So, going back to what a solar cell is, it's a certain panel that needs energy in order to help power anything of sorts, such as electricity. And so, as humans, we've come to harness the sun's energy by using its rays that hit on the solar cell in order to produce electrical current. So going up to the makeup of a solar cell, it's made up of metal bases, silicon, and protective glass. And as we can see, it's very tightly packed together, which is really remarkable that something so small can generate power for us. So we have what's called silicon, N-type and P-type. So the N-type just means it's negative, and P-type is for positive, and silicon is the type of material that the solar cells are made out of. And it's all covered in what's called a protective glass. So what it does, so one solar cell by itself won't be able to generate a lot of useful current that we need. So by combining many multiple cells together, we get what's called a solar panel. And having multiple solar panels will in turn help us generate the energy that is required for many of our houses to be on, or electricity, or a school of sorts. So this picture here is a picture of our UC Merced solar farm. And as an example, many panels help to generate power throughout the whole campus.
So now I will be talking about solar cell efficiency. Are solar cells efficient? Well, in comparison to other products and materials, solar cells are considered more energy efficient than others. As you can see from this diagram, the sun radiates onto the solar panels, which therefore generates power. How this works will be explained later in this video. As of right now, using the sun, which radiates every single day, is an effective way to generate energy and be more efficient. The heat and radiation that the sun emits are what we know as solar energy. This has been a topic of much interest for many years, and there have been new discoveries as to how to make the solar cell applications be more efficient and less cost effective. The greatest thing about solar energy is that it is more accessible to the common people rather than fossil fuels. Another advantage would be that it is less expensive to produce compared to other conventional energy sources, and because it uses the sun as its main power source, it is available all around the world. So as of right now, the current research has been to find ways in which solar cells can be modified, which will yield to a more cost-effective product that is also energy efficient. As you can see from the diagram, there have been 3 different solar cell designs geared towards producing the most efficient and low-cost cell. In the first category, known as the first generation, there are 2 types, monocrystalline and polycrystalline solar cells. During the making of monocrystalline solar cells, the Czochralski process is used to break up the silicon into smaller parts. This process is actually one of the most important in the production of semiconductors. The second wafer-based cell is the polycrystalline solar cell. This type of solar cell is one of the most popular because it is easier to fabricate and less expensive to make than the monocrystalline. However, it is less efficient. The next type of solar cell introduced are the second generation thin film cells. These include the amorphous silicon and the cadmium tellurium solar cells. Compared to the first generation solar cells, these two types of thin film solar cells are much more economical and have a thinner light absorbing layer. The substrates used in the making of the amorphous silicon thin film require a smaller amount of energy. This type of cell is available in many places and it is very cost effective given the materials needed for its manufacturing are very cheap. As for the cadmium tellurium solar cell, it is also cost effective to make. However, compared to the amorphous silicon cell, it is much more energy efficient. And moving on to the next category, the final type of solar cells that have been created are the third generation new emerging technology solar cells. These include nanocrystal, polymer, perovskite, dye-sensitized, and concentrated-based solar cell. Overall, these solar cells are the highest technology-based cells. The nanocrystal solar cell has excellent thermal stability and it can be designed to be flexible. More information on these types of cells will be provided in the next slide. Now, going back to the nanocrystalline solar cell, it is actually 50% less expensive than conventional silicon cells and the installation time is short compared to the first generation solar cells. In terms of efficiency, the perovskite and concentrated solar cells surpass all the other types manufactured. The perovskite solar cell has an energy efficiency of 31%, while the concentrated solar cell has an efficiency of about 50%. The key difference between these two types of cells is that the concentrated solar cell requires a longer installation time and a larger space. In comparing the three panels shown in the diagram, monocrystalline, polycrystalline, and thin film panels, these types of generations, the perovskite solar cell is the most complete in terms of both cost effectiveness and energy efficiency.
How does it work? Solar cells, also referred to as photovoltaic cells, use sunlight to generate power. Through the photoelectric effect, photons get emitted from the sun and hit the solar cell. The solar cell generates volts of electricity and an electric current. That is just a basic explanation of how solar cells work, but let's go more into depth. Once the photon hits the cell, it makes the electrons in the silicon go out of place. The loose electrons then go through the two layers of silicon. First, the N-type, then the P-type. In the P-type layer, the photon releases energy to electrons. Then they use the energy to jump back to the N-type layer to exit into the circuit. In this electric field, the electrons begin to flow, thus creating an electric current. As the electric current is generated, the electrons are being collected on the side and end up going into a wire which then converts the energy to power. And this is how all the cells come together to generate power for your house. What is the future research with these solar cells? As of right now, the perovskite solar cells are the main area of future research. They still need to be perfected so that they can be used commercially. Some of the issues they still need to figure out are the toxicity and durability of the cells. They are also working on increasing the efficiency of conversion to electricity and reducing the cost.
Quantum dots and solar cells. So what are quantum dots? They are very small crystals, they are semiconductors, and they are 2 to 10 nanometers in diameter. Quantum dots are being used to improve the efficiency of solar cells. Currently, solar cells are about 34% efficient, and this is due to certain limitations like blackbody radiation, radioactive recombination, and spectrum losses. Quantum dot solar cells use photovoltaic materials instead of using bulk materials like silicon. So, bulk semiconductors versus quantum dot semiconductors. There are several differences between them. In bulk semiconductors, you have a fixed energy gap width. So to change the gap width, you need to change the material in order for a different wavelength of light to be emitted. On the other hand, quantum dot semiconductors use photovoltaic materials like cadmium. The energy levels of quantum dots become discrete due to its nanoscale. Therefore, it can be compared to the particle in a box model. So how are quantum dots and the particle in a box model related? Quantum dots can be described using the particle in the box model because of this quantum confinement. Using what we know about a particle in a box model, we can conclude that as a quantum dot diameter decreases, the separation of the energy levels increases. We can see in this picture that the smaller the dots are, the wider the energy levels are. So changing the radius of the quantum dots changes the wavelength of the absorption and emission of light. Since properties of quantum dots change according to the size of the particle, scientists are producing quantum dots based on different semiconductors in order to change spectral coverage, thus increasing efficiency.